Hey folks, Shubh here, and today we will study what is Eigen layers AVS. So AVS stands for Actively Validated Services. Now, what are these services? AVS can be anything that has a backend. So let's say I want to create a bridge, but I want a decentralized or a sufficiently decentralized infrastructure for it. What I can do is I can create a AVS for that. So AVS basically has three parts: operator, aggregator, and the task manager. So task manager is the one who manages a particular task. Let's say bridging is our task. So what operator will get is a task to bridge tokens from layer A to layer B, and the operator will do that task. That is the main heart of the AVS is an operator. The aggregator gets that particular task that is being done by the operator with its signature, that can be ECDSA or BLS, and aggregator gets all the tasks from various operators, and further it checks whether the computation or the task which is performed by the operator is correct or not. And if it meets the majority, if it meets the quorum, if it meets the majority, it's marked as correct and it's passed on as output to the service, that is the AWS, or the bridging of tokens is being done. Now, this is a complex example. Today, we'll be taking a easier example, that is querying a number, and we'll square a number every 10 seconds on top of eigenlayer. So, who all can run these services? There can be operators. So the operators can stake some amount of ETH or LSTs, and they can do some computation and get resources in return or rewards in return. And if they perform wrongly, then their stake will be slashed. Now, this was basic understanding of AVS. Now let's understand what are the trust or the programmatical trust that are provided by EigenLayer. So basically there are three type of trust that are being provided by EigenLayer. First is economic trust. So provides financial trust by backing the service with staked assets, that can be LSTs in form of ETHs. Then second is decentralized trust, provides a network of node operators which are geographically independent. So let's say if your service requires the node operators to be in various regions of the world, then that is possible by EigenLayer, as the node operators of EigenLayer are in different portions of the world. And the third and the last one is Ethereum trust. So Ethereum trust provides proof that Ethereum validators will construct and add the block with computation in it if it's formed correctly, and passes the particular quorum set by the block producer. Now, you can have any one trust for your AVS, or you can have combination of trust. Let's say you need economic trust and decentralized trust both together, then you can form the AVS service in such a way that it gets the financial trust from EigenLayer in terms of financial support, plus the node operators are from different regions of the world. Let's say two from every continent. So that is being possible. Now this was a basic understanding of programmatical trust which EigenLayer provides. Up next we will clone repo that is called as Incredible Squaring AVS by Layer Labs. I'll link it in description and in my blogs, you can find it there. So I have cloned it in my VS Code, and I have cd into contracts and runs forge install, so that I can save some of your time. Now what forge install does is it installs all the packages or all the smart contracts which will be required by the smart contracts in our AVS. So why do we have a smart contract here? So the smart contract also checks whether the computation or the squaring that is being done by the operator is correct or not, and it returns a response in following way. If the computation is correct, it returns a good response, or else a bad response is returned. Now let's move on to how we can run the AVS. So first you need to install Docker. So I have already installed Docker and it should be running. So you can just like run it in background. You can minimize it and go to your VS Code. Second is you should be installed a Pretty Zap. I think Pretty Zap package. I link it, which is required for like command line, one of the dependencies for this project. I'll mention them in the blog. Don't worry about it. So what the important part is the makefile. Give me a sec. Okay, so the issue was that we were in contacts directory and there the command line was not able to find the makefile. So I cd into one branch up and now we can find the makefile. So what are all these commands, various commands that have been listed here? So the first one, that is build contracts, is used when you update any contract. You have to build the contract again. And second command, that is deploy eigenlayer contracts to Anvil and save state, is used to uh, deploy the build contract on eigenlayer Anvil. For those of you who don't know what Anvil is, so like Anvil is a local blockchain which is run on your computer, and it acts like a real blockchain but no funds are being used. Plus you don't have to get any funds from the faucet to work or to build on Anvil. So we'll spin up an Anvil ourselves in this project and we'll do all transaction on Anvil itself. Then the third command is to deploy incredible squaring contract to Anvil and save state. And the fourth one is deploy all to Anvil and save state. So like once you run the build command, you can just run the deploy all to Anvil command so that you don't have to run the above two commands. Third is start Anvil chain with eigenlayer and AVS deployed. So this command is basically used when uh, when you don't do any changes to the build contracts, you can directly start the Anvil chain with the eigenlayer deployed on it. And as we haven't done any changes on it, we'll run this one only. So to run it, we'll simply do make and paste the command. And if we check our Docker, then Anvil node should spin up there. So as you can see here, an Anvil is here. We'll come back to VS Code. We'll create another bash. Or simple terminal will also work. And we'll run a operator now. Or yeah, start. So as you can see here, operator is being registered to eigenlayer, and this is a transaction as for the transaction. And now the operator is live, and every 10 seconds it will pass a particular variable or a particular number to itself and square it and send it to aggregator. So up next we'll start the aggregator. So if we see here, we are giving outputs or we are sending numbers to the operator, and it's doing its thing and send it to aggregator. As you can see here, this was the task 0, this is task 1. Here as you can see, number to square was 0. Here number to square was 1, then number to square was 2. And let's see, here we have got number to square was 3. The task index was 2. And here we get the number squared as 9. So this computation was all done by the AVS, and it was returned as a response of this with the BLS signature. And yes, so this was a main goal, to run AVS, and we have ran it. So it will continually do it until we end it. As you can see, the number to square was 7 and we are getting 49. That is its squared number. So this will keep continuing and increasing number one by one. So it was an easy task. I believe in you all. You can easily do it. Give it a try. If you have any doubts, you can reach out to me on ashubh, AEYSHUVH on Telegram. I'll be happy to help. Basically, it's just 3 steps: spin up the anvil, start operator, and then start aggregator, and you should be able to spin up your own AVS for starter. If you want to do any changes, it would be a bit hard. You should be good in Go and Solidity. You would need files. So like you can go on each and every file like aggregator, or else in the source you can find the incredible squaring task manager, or the operator where the go where which is written in Go, like this one operator. Here you can go to operator.go, and you can change the operator to your logic, and they'll function in that similar way. So this was all for this tutorial. I hope you like it, and please try it out, and all the best for this. Thank you. I hope you like this.